Hello children, my name is Shweta and I am a postgraduate in chemistry with 10 years of teaching experience in international schools and colleges. I hope my videos will help you understand few concepts in chemistry better. Today we are going to study about chemical reactions. What are chemical reactions? Before that, let's have you studied about physical and chemical changes before? In your smaller classes, you must have studied there are two types of changes, physical changes and chemical changes. What are the examples you studied? Boiling of water, melting of ice, these are all physical changes. So what happens when you boil water? When you boil water, the water gets converted to steam or water vapor. You can collect this, cool it and get the water back. So physical change is a reversible change. The identity of the substance is not lost in a physical change. But in a chemical change, which is an irreversible change, new products are formed or new substances are formed as a result of chemical change, and they have properties which are completely different from the reactants. Bonds are being broken in the reactants and rearranged to form new bonds in the product. For example, we have the neutralization reaction. In your smaller classes, you must have studied the reaction between an acid and a base, isn't it? What happens when an acid reacts with a base? You get salt and water. Let's take an example of neutralization reaction. NaOH plus HCl giving you NaCl and H2O. NaOH plus HCl giving you NaCl plus H2O. This is an example of a neutralization reaction. The bond between NaOH and HCl, this bond is broken, and together they form water, which is this. What is left is NaCl. Na and Cl, they join together to give you NaCl. This is sodium chloride or salt. This is an example of a reaction in which bonds are broken, rearranged to form new products, and these products formed do not have any properties of the reactants. These two are called reactants, and what is formed, they are called products. So this is a chemical change. So chemical change is a process in which one chemical substance gets changed, or one or more chemical substance gets changed to new chemical substances. You have 3 experiments to learn. The first one is the reaction between magnesium and oxygen. This is the first example that you have to learn. In this experiment, you need magnesium ribbon which is 3 to 4 centimeters long. What you should do first is clean the magnesium ribbon. Magnesium is a very reactive metal. It will react with the oxygen in the air to form stable magnesium oxide, which is seen on the surface of the magnesium ribbon. You first have to clean the magnesium ribbon to remove the magnesium oxide. Okay, so first you have to clean the magnesium ribbon using a sandpaper so that you get clean magnesium, not coated with magnesium oxide. Then you need a burner, and then thirdly you need a watch glass. So what are the 3 things you need? You need a magnesium ribbon 3 to 4 centimeters long, you need a burner, and you need a watch glass. So you ignite the magnesium ribbon. On ignition, you get a white dazzling flame. This is the observation. Magnesium ribbon on burning gives a white dazzling flame. Then you get white powder, which is collected in a watch glass. So I can show you using a diagram. You should have a burner or a spirit lamp. Okay, and you keep the magnesium ribbon. Here the flame. This is the magnesium ribbon, cleaned magnesium ribbon. Then you have a watch glass here. After burning, you get white powder on the watch glass, white powder of magnesium oxide on the watch glass. Let's say magnesium reacts with air or oxygen. Oxygen in the air basically is reacting with oxygen, and you get magnesium oxide which is a white powder. Okay, this is the reaction. Magnesium ribbon on burning, or it combines with air, or rather oxygen in the air, to give you magnesium oxide, which is a white powder. This is the first experiment. You should have a burner or a spirit lamp and use a magnesium ribbon which is clean. Then you get a white dazzling flame on heat. Burning magnesium gives a white dazzling flame. This is the observation, and it is very commonly asked question. What is the observation when you burn or heat a magnesium ribbon? It is white dazzling flame, and in the watch glass you get a white powder of magnesium oxide. Okay, this is the first experiment that you should learn. The second experiment is reaction between lead nitrate and potassium iodide. For this you need a test tube. You know what a test tube is? Okay, take a test tube. In that take lead nitrate, which is colorless, add potassium iodide. On adding potassium iodide, you get a yellow precipitate, a beautiful yellow precipitate of lead iodide. Okay, so this is also a chemical reaction. We can represent the reaction using an equation. Lead iodide is formed. Formation of lead iodide. So what you need is, you have a test tube, you take lead nitrate, okay, then you have to add potassium, potassium iodide, you add potassium iodide. So lead nitrate plus potassium iodide gives lead iodide and potassium nitrate. This potassium iodide is a beautiful yellow precipitate. Okay, so you need a test tube. You take lead nitrate in it. To this you add potassium iodide. On mixing of the two, you get a yellow precipitate of lead iodide. That is the second reaction that you should know. And thirdly, you have the reaction between zinc and dilute hydrochloric acid. For this you need a conical flask. So in a conical flask you will take zinc granules. Zinc granules are small bits of zinc. Into it you will add dilute hydrochloric acid or dilute sulfuric acid. You can cover the conical flask using a cork, and in the middle of the cork you can insert a glass tube. So after a while you see small bubbles around the zinc granules. What are these bubbles? These bubbles are hydrogen gas produced as a result of chemical reaction. And this gas can be liberated. The liberated gas can be collected using the glass tube. Did you understand? So the third experiment requires zinc granules, dilute hydrochloric acid or dilute sulfuric acid, and a conical flask basically. So in the conical flask you take zinc granules. Third experiment, you need a conical flask. In this you add zinc granules and you take dilute hydrochloric acid or dilute sulfuric acid. So you have zinc granules and you have a cork and you can insert a glass tube there. So as a result of the reaction, zinc and sulfuric acid, you get zinc sulfate and hydrogen gas which is liberated. So you have hydrogen gas which can be collected. Around each zinc you get bubbles. That is the observation. Formation of hydrogen gas is can be understood by seeing the bubbles. So this bubbles can be collected using a glass tube. So this is the third reaction. So you have three reactions to learn. One between magnesium or the oxidation of magnesium. The second is a reaction between lead nitrate and potassium iodide, and the third one is the reaction between zinc and dilute hydrochloric acid. So in any chemical reaction you can expect four changes: change in temperature, change in state, change in color, or liberation of gases. Either any of the four can happen, or two or more changes can happen together. For example, in some reactions you get a change in state and change in temperature, or you can get a change in color and a change in temperature. So it can be either way or just one. You can identify a chemical reaction with any of these four changes happening: change in temperature, change in color, change in state, and finally liberation of gas or gases. So these are the points that you need to remember. A chemical reaction is a chemical change or a change in which one new substance is getting converted to a new substance. It is an irreversible change. So today's class you have learnt about chemical reactions, a few examples of them, and how will you identify a chemical reaction by the changes that will happen during a chemical reaction. In our next class, I'll teach you how to write these chemical equations and how to balance them. There are two types of equations: skeletal equations and balanced chemical equations, and it's very important to know how to balance a chemical equation, which is a really trial and error method. It's only out of practice that you will learn. So children, until then, goodbye.